This question asks you to convert 89.63 liters to microliters. And this is something that you should get in the habit of doing using what's called the factor label or dimensional analysis approach. So one of the first things that we need to know in order to solve this problem is the unit conversion for going from microliters to liters or liters to microliters. So if you memorize the prefix table, then you will find that there are 10 to the negative 6 liters in 1 microliter. Alternatively, you could choose to remember this as there are 10 to the positive 6 microliters for every 1 liter. Now, there is a metric prefix table. You should commit those to memory. Unfortunately, they're one of the things that you must memorize for this class. For example, there are 10 to the 9 nanometers in a meter, and this uses the prefix for whatever unit that you're in and gets it to the base units. Another example of this would be milliliters, for example. So in 10 to the negative 3 milliliters, this is 10 to the negative 3 liters is equal to 1 milliliter. Or 10 to the 3 milliliters for 1 liter. Now, this is where we're going to be for this problem, because we're going from liters to microliters. And remember, these are unit conversions, which we can rewrite as either 10 to the negative 6 liters is equal to 1 microliter, or we can flip this, because they are equivalent. We could write 1 microliter over 10 to the negative 6 liters. Either way, I can flip this, because they are equivalent, to put them in a position to help me out mathematically. Now let's take a look at what that means. So, if we consider this a conversion factor, we can use either one of these to convert liters to microliters. And the way that I like to set this up is by first writing what I absolutely know. I know that I have 89.63 liters. And then I like to write exactly where I'm going. And I'm going to microliters. So now what I need to do is place some fraction or conversion factor into my equation so that when I multiply it through, I cancel out liters. And immediately I can identify that this version will allow me to go to microliters because it has 1 microliter in the numerator and 10 to the negative 6 liters in the denominator. And when you multiply fractions, you can cancel out things that are in the numerator and the denominator. This leaves me with just microliters in my numerator, which is what I want in my final answer. Now, if you were to plug this into your calculator, what you would find is that you would get an answer that is 8.963 times 10 to the 7 microliters. Otherwise, 8.963 times 10 to the 7 microliters. Now let's see how I could have used this other one to get to the same answer. So, 10 to the 6 microliters is equal to 1 liter. So I know where I'm starting, 89.63 liters. I know that I need to put something here that cancels out liters. And I know that I need to put my final answer in microliters. So now, if I plug in 10 to the 6 microliters up top, and 1 liter in the denominator, then when I multiply through, I still get the same answer, which is 8.963 times 10 to the 7 microliters. You should get used to setting up your problems in this way, because this is called the factor label approach, and we're going to use it throughout the semester, even once we get beyond unit conversions. When we get to concentrations, when we get to molar mass, we're going to use this approach of using conversion factors to allow us to perform our calculations. And what's cool is that if you monitor the units that get canceled out and don't cancel out, you should always end up with an answer in the correct units just because they canceled out or didn't cancel out. And that's how you can check your answer every time to make sure that you've got it right.